Hello and welcome to today's class. We are going to look at multiplication of matrices. So in the previous video, we looked at scalar multiplication. Quite a build up into today's lesson, that is multiplication of matrices. So in this class, we are not going to multiply a scalar and a matrix. No, we are going to attempt to multiply a matrix and a matrix by a matrix. So one thing I want to put across before we do any example is the issue of compatibility. We saw that when we were adding and subtracting, we needed to check for compatibility, and in that particular case, the matrices before adding and subtracting had to have the same order. So compatibility when multiplying matrices by matrices is different. Well, when we're doing scalar multiplication of matrices, we didn't have, there has not to be an issue of compatibility there. However, when you're now multiplying a matrix and a matrix, then you have to first of all check for compatibility. And we always say that if you say, let's say you are having a matrix with order A by B, all right? If you're having a matrix by order A by B, and you're multiplying it with another matrix, then it has to be of the same. It has to, let's say another matrix. Before I go ahead of myself, let's say you're multiplying it by another matrix of order B by C. Okay, then for these matrices to actually be compatible and ready for multiplication, then these two numbers, okay, that is the two B's, the one at the end of the first one and the one at the beginning, have to be the same. All right, have to be the same. For example, a matrix of order 1 by 2 and order 2 by 3 will be compatible. Why? Because of this similarity there. All right. Okay. So that is one. Then another thing, maybe a matrix of order. We can also say a matrix of order 2 by 3 and a matrix of order 3 by 1 can also multiply each other. They are compatible. Why? We always check for these two numbers there. Okay, the one at the end and the one at the beginning of the other order. All right, so that is it when we're looking for order. Then we always expect that now that they're compatible, we can also tell how the resultant matrix will look like. So in this particular case, if I was to multiply these matrices, then it would give me a matrix of order A by C. Okay, the resulting matrix will be of order A by C. These remaining letters right there. All right, so in this particular case, the resultant matrix will be of order 1 by 3. Okay, it will be of order 1 by 3, and in this particular case, it will be a matrix of order 2 by 1. 2 by 1. So that is it when you're checking for the issue of compatibility. So the most important thing is you always want to check on these on the number of column and the number of rows for the matrices before the compatibility of that, before you actually go ahead and start multiplying. All right, why don't we go ahead and do an example, then see how this actually works out. Awesome. So for our first example, we're going to attempt to solve this particular problem. So we're supposed to multiply these two matrices. You're supposed to work that out. And so the first thing you want to check is if they are compatible, okay? Compatibility, all right? So that is what you want to first check. So what is the order of the first matrix? You can see it only has one row. So it is 1. And how many columns? By 2. And 2 columns. All right, and in the second matrix, what do you see? How many rows are there? 1 and 2. All right, so for the second matrix, we have 1 and 2 rows, so we have 2. And how many columns? Just 1 column. So for us to check the issue of compatibility, what do we look at? We look at these numbers there. If they're the same, then we say that they're compatible. So in this particular case, it actually we can actually go ahead and proceed with the process of multiplication, as these two matrices are already compatible. Then of course we can almost tell, the resultant matrix, the order will be 1 by 1. Okay, so that is to mean it has one row, one column, one element. 1 times 1 is equal to 1, so one element. So we're actually expecting one element matrix here, all right, in this particular problem. All right, so here is how we go ahead to then multiply these two matrices. Usually when you're multiplying matrices, it is row times columns. Okay, it is rows that multiplies columns. Rows multiplying columns. Remember, rows are the what? The horizontal arrangements, and columns are the vertical arrangements. So this here is a row, this here is a column. All right, so to multiply this matrix here, we're going to have this row multiplying this column. All right, this row matrix here multiplying this column matrix right there. All right, so this is how it's going to look. So we are going to have 5 multiplying 6. Okay, so it's going to be 5 times 6. Okay, plus 5 multiplying 5. So 5 times 6 and 5 times 5. All right, plus 5 times 5. Of course, remember we are adding. So by multiplying this row and this column, we're going to get one element. We just want to get one element. All right. And since there is no any other row and column to multiply in this particular case, that will be it. So we're going to basically take 5 times 6, and that's going to give us 5 times 6 is going to give us 30, plus 5 times 5 giving us 25. And so this is going to give us a matrix of order 1 by 1, which actually happens to be 30 plus 25, which is 55. And so this here is the result of multiplying these two matrices. This here is a matrix. Okay, you can see it's in a rectangular arrangement with only one row and one column. All right, so it's a matrix of order 1 by 1. All right, so that is what we get when you multiply a row and a column. You just get the one number. All right, why don't we conduct an even more challenging problem and see what we get in the second example. All right, so for our second problem, we are going to multiply this particular matrix and see what we get. So first of all, we want to check on compatibility. All right, so how many rows are here? So in the first one, for compatibility, we want to check on that compatibility. All right, so we are having the first matrix as is of order 1 by 2. 1 by 2. It has one row and two columns. And the second matrix has how many rows? Has 2 rows, 1, 2. And how many columns? 1, 2. Okay, so is it compatible? We check for these here. So they're 2 and 2. That means that they are compatible. If they're similar, then they are compatible. Then, of course, we're expecting that our resultant matrix will be of order 1 by 2. Okay, 1 by 2. That is to mean it's going to have one row and two columns. One row, just one row and two columns. Awesome. So anyways, we are, so as I said earlier on, rows multiply columns. With matrices, rows multiply columns. All right, so in this particular case, from here, let me just have an open parenthesis there. So I'm going to take row 1 multiplying column 1, row 1 also multiplying column 2, of course, yeah, to get our final answer. Of course, row 1 times column 1, let us start with that. So 2 times, it's going to be 2 times 2, okay? It's going to be 2 times 2, all right? Plus, that is 2 times 2 plus 1 times 0 plus 1 times 0, okay, to give us the first element right there, Then for the second element, we're going to take again, that was row 1, column 1. So we go to row 1, column 2 now, all right? So for our second element, we're going to get 2 times 3, 2 times 3. Remember, it's row 1, column 2 now. The first one was row 1, column 1, and now the second one is row 1, column 2. So basically what you're getting here is that a row must always multiply all the columns. Okay? So for this single row, it's multiplying row 1 to get us, column 1 to get us the first digit here, and then it's multiplying the second column to get us the second digit right here. So it's going to be 2 times 3, okay? 2 times 3 plus 1 times 4 plus 1 times 4. Okay, all right. So basically note that this is going to give us 2 times 2 is going to be 4, plus 1 times 0 is going to be 0. 2 times 3 is going to be 6, plus 1 times 4 is going to be 4. All right, so that's going to give us a general matrix of 4 plus 0 giving us 4, and 6 plus 4 giving us 10. So it's going to give us a matrix 6 by 10 here. All right, 6 by 10, which actually is the matrix of order 1 by 2 that we were expecting as our resultant matrix. Anyway, that is the product of multiplying these two matrices in this particular example. Very easy. So it's one row multiplying each column, and if the first row multiplies the first column, it gives us the first digit here. All right, and the second column gives us the second digit right there, and it always goes like that. Let us handle a much more complicated problem so that at least you're able to see what I'm talking about. All right, so for the last problem, we want to check on compatibility. So what is the order of this matrix, the first matrix? How many rows are there? We are having 2 rows. How many columns? 1, 2. So it's 2 by 2. That is the order of the first matrix. The order of the second matrix, we also want to check the number of rows. How many rows are there? We're having 1, 2. So we're having 2 rows. And how many columns? 1, 2. We are having 2 columns. All right. All right. So we check for compatibility by looking at these numbers here. All right, so this is 2, this is 2, they're similar. That means that they are compatible. So if they are compatible, then it means we can actually multiply the matrices. We can then go ahead and multiply the matrices. In case they're incompatible, then we don't proceed. We just say that these matrices are incompatible. Then, that means they can't be multiplied, basically. So if they're compatible, it means that they can be multiplied. And of course, we're expecting that the resultant matrix is going to be of order 2 by 2 as well. So anyways, with that in mind, now let's try and see what we get out of multiplying these matrices. Now, a row multiplies a column. All right, and a row multiplies all the columns. Okay, so a row multiplies a column, and each row multiplies all columns. Each row multiplies all columns. All right, so in this particular case, we are having row 1, and how many columns are we having here? 1, 2. So row 1 is going to multiply both column 1 and column 2 of the matrix that is on its right. All right, so we're going to take 3. We're going to start with column 1, okay, to get the number that it should be, at the position R1, row 1, column 1. All right, so we're going to take 3 times 2, okay, for column 1. We're going to take 3 times 2, plus 2 times negative 2. 2 times negative 2, all right, so 2 times negative 2. All right, so we're supposed to add that, and that should give us a single number right there. All right, then so that is for that particular column. So this is this row multiplying this column, and remember, it's supposed to multiply all the columns within this matrix. So we have row 1 multiplying column 1, and we're supposed to get this. And so we also have row 1 multiplying the second column. All right, so to give us the number at row 1, column 2 right here. All right, so that's going to be 3 times negative 1. All right, 3 times negative 1, and that's going to give us 3 times negative 1 right there, plus 2 times 4. 2 times 4, of course, plus 2, right? 2 times 4, that's 2 times 4. Okay, that is row 1 multiplying column 2, all right, to give us the number at row 1, column 2 right here. So we've seen what we've done. Row 1 has already multiplied all the columns. So row 1 multiplying column 1 gives us what we're going to get from multiplying and adding these particular numbers here. Row 1 multiplying column 2 gives us this particular thing. So I have it as plus 3 here because I almost wrote negative 3. So it was 3 times negative 1. Of course, 3 times negative 1 is negative 3, but I almost wrote the answer without really showing you what was happening. So anyways, that is what's happening. We're just basically taking 3, which is a positive number, times negative 3 right there. All right, so anyways, For the second row, so that is it for row 1. For the second row, which is going to give us the numbers in the second row in our resultant matrix here, we're going to take 0 multiplying all the columns again. That is 0, 0, negative 2. That is the second row multiplying all the columns again. So it's going to be 0 times 2. All right, so it's going to be 0 times 2 plus negative 2 times negative 4. Negative 2 times negative 4. Negative 2 times negative 2 times negative 2, sorry, negative 2 times negative 2, negative 2 times negative 2, all right? So that is it for that column. And for the second column, it's going to be 0 times negative 1. It's going to be 0 times negative 1, 0 times negative 1, plus negative 2 times negative 2 times 4, negative 2 times 4 there, negative 2 times 4 right there. All right, so we're going to multiply and add whatever numbers we have in this expanded matrix right here that is yet to be complete. So in here we're having 3 times 2, and that will give us 6. All right, 3 times 2 will give us 6, plus 2 times negative 2 will give us negative 4. All right, 2 times negative 2 will give us negative 4. All right, so here we're going to have 3 times negative 1, and that will give us negative 3. 3 times negative 1 will give us negative 3, all right, plus 2 times 4, which will give us 8, all right, 2 times 4, which will give us 8, all right. So coming down here, we're going to have 0 times 2. 0 times 2 giving us 0, plus negative 2 times negative 2 giving us 4. All right, negative 2 times negative 2 giving us 4 right there. All right, so here we're going to have 0 times negative 1 giving us 0, plus 0 times negative 1 giving us 0. Remember, any number multiplied by 0 is 0. Okay, plus 2 times 4, negative 2, sorry, negative 2 here times 4 is going to give us negative 8. All right, so what happens when we add and subtract where or add all these numbers right there? So it's going to be 6 plus negative 4. All right, 6 plus negative 4, which is the same as 6 minus 4, is just going to give us 2. All right, so in here we're going to have negative 3 plus 8, and that is going to give us 5. All right, and so 0 plus 4 is going to give us 4, and 0 plus negative 8 is going to give us negative 8. And that there is our resultant matrix, the matrix that we're getting when we multiply these two matrices, of course, which is of order 2 by 2, as you can see from our compatibility test. So that is it with how we multiply matrices. It's basically rows multiplying columns, and each row has to multiply all the columns, okay? Like row 1 multiplied column 1 to give us 2 here. Row 1 multiplied column 2 to give us 5 here. All right, row 2 multiplied column 1 to give us 4, and row 2 multiplied column 2 to give us negative 8. So basically that is the concept of multiplication, where a row multiplies each column to give us the numbers in respective rows, okay, and columns. All right, so that is it for this particular lesson. If you have any question, drop it in the comment section. Otherwise, have an awesome day.